Let me give you now a demo on how to use the DevC to run or execute a program. Let's open DevC from the desktop. Double click the icon. Okay, so this is the DevC IDE. IDE stands for Integrated Development Environment. Okay, so the first thing we do is to create a new program. So you could click this button, or you could go to File, New, and then click Source File. Okay, so there are two options to create a new program. Either you click this button, or you go to File, New, and then click Source File. Okay, or you press Control N. Say we click this one. And say we have this program already, which is equivalent to our algorithm and pseudocode, and which is to add two integers. So just ignore this for a while. This is simply, I am putting a comment. This is not part of the program, but just to add some description on the program. So this is a comment delimiter, and from this symbol, double forward slash, everything on that line straight to the end are comments. They are not part of the executable code. I would like to say here, import all built-in functions defined in stdio.h C library. So stdio.h, this is a header file where that header file contains definitions of built-in functions for input and for output. That's why stdio, which means standard input output functions. And in here belongs the built-in function printf, which is used to display something on the monitor, and scanf, used to get input data or input values from the keyboard. So since we are using printf and scanf, and these are defined in stdio.h header file of the C library, then we need to include that in our program. So you are like importing those built-in functions into your program so that you can use them here. So remember, the first instruction in our algorithm is to input or get the first integer. Okay, so this is the equivalent instruction in C programming language. Okay, so get the first integer. This is to get input integer from the keyboard. But of course, you have to prompt or tell the user what to do by displaying this on the screen using a printf. And the instruction for the user to do is to enter the first integer. After that, you instruct the user to do enter the second integer, which is y. Okay, and then the user inputs into the keyboard the value of y. Once you have now the value of x and y, you can add both and put the result in z, and then you use printf again to display the values of x, y, and z, and the percent d there is a conversion specification for data type integer. Okay, since the data type of variables x, y, and z are integers, as declared on top, int is integer. So this is our variable declaration, declaring x, y, and z. So save this by clicking that button, and then say we put that somewhere here. Let's call it sum.c. You have to include the .c extension because by default, it will be saved as a txt file or a text file. If you will not put the .c, when you check the folder, what you have there is sum.txt, not .c. The C compiler will not run it because the extension is not .c. So it's not a C program if the extension is not .c. So this will tell the compiler that this is a C program. So you need to include the extension .c when you save the file. And then after saving, take note you have there the file name of the program. So the first thing to do is to compile. Compile means to translate the C program language into true executable language of the computer, which is the binary 1 and zeros. So here we have in the output tab or window the compilation results. So there are no errors, there are no warnings, and we have generated the true executable code, the one with the .exe file name. This is now the binary equivalent of the source code program, which is this. We could now run it by clicking this run button. Okay, so we have here now in our output window the output. So first instruction to be executed is this one. It displays this on the screen. This program computes the sum of two integers, and then you say next is enter the first integer x. The blinking cursor is the action of the scanf, in which the computer is waiting for the user to input an integer value for x. So say we input 4. Press enter. Next is this one is executed. Enter the second integer y. And the scanf here is the action of this blinking cursor. So it's like the computer again is waiting for input from the user. That is your scanf in action. So say we input 7. So x is 4 and y is 7. Then we press enter. This is executed, the z gets x plus y, and then the last statement to be executed is the printf, which is the sum of. So what appears here is the value of x. The first %d is the place where the value of x is displayed. And then the second %d is to display the value of y. And the third to display the value of z. So in that order, x, y, z. So this is for x, for y, and for z. Okay, so what we have here is indeed x 4 and y is 7 and the sum z is 11. So this is now the sample running session of our program, and you just ignore this one. This is simply added by the dev.c compiler. You can press enter to close the output window. So again, these three terms, algorithm, program, pseudocode, are similar in the sense that these three are all set of instructions to solve a problem or accomplish tasks. And the difference now is that the algorithm is a draft solution written in human or English language, and the pseudocode is written in both human and programming language. While for program, this is now written in a programming language. Okay? So again, algorithm is written in human or English language. Program is written in a programming language like C programming language, and pseudocode is written in both human or English and programming language. Now let's move to discuss the two kinds of algorithms. Algorithms can be partial algorithm or total algorithm. Partial algorithms are those algorithms that is intended to run 24/7 or that might not end. Examples to this are online programs like the computerized airline reservation ticketing systems of PAL or Cebu Pacific. You can go to the website of PAL or Cebu Pacific and make reservations or buy a ticket online. So the user can go to the website any time of the day, and therefore the program running on the browser must be available 24/7. Programs like those, the underlying algorithm, are called partial algorithm. Another thing is the programs running on ATMs, automated teller machines, right? These ATMs are running 24/7. So the underlying algorithm of those programs running on ATMs are partial algorithms because they are intended to run 24/7 and they might not end. Unless, of course, the bank will decide to shut down the ATM for some troubleshooting activities because there are no more money inside the machine, or maybe some technical problems. So they have to shut it down. So that's the only time. But without troubles, it should be running 24/7. The second kind of algorithm is total algorithm. This is what we usually do, okay? So this is an algorithm that is guaranteed to end. So it has a definite start and a definite end. Like our program, recall sum.c, it has a definite start. The start is when we ask for the first input integer x, and then the end is when we display or output the value of z, which is the sum. So total algorithms are those that is guaranteed to end. It has definite start and end. It's not intended to run 24/7, while partial algorithms are those that might not end or that is expected to run 24/7. There are two kinds of programming languages. The first one is high-level programming language, and the second is low-level programming language. The high-level language resembles the human language, or it is closer to the human language. Okay, these are examples. So we have here C, we have other. This is in the past, Pascal, we have Fortran, Lisp, Prolog, and we have also Java and Python and many others. The second, which is called low-level programming language, this resembles the computer's language or the computer's native language. This is closer to the computer's native language, which is the binary language. So if we're going to write in here the levels of the programming languages, so we consider the human language as the highest, and high-level languages are somewhere here, which are like Pascal, C, Fortran, Lisp, Prolog, Java, Python, and many others. They are somewhere here in the hierarchy. And then the low-level languages are somewhere here. And the lowest level language is the machine language. This machine language is the native language of the computer. And another term for this is binary language, because this language consists of only zeros and ones. So maybe it would look like this: 0 1 0 1 1 1 1 0 1 1 0 0 0 1 0. So we call this the binary language or machine language. Okay, this is a code that the computer can understand, but of course the human cannot understand this easily. So here is the human at this level. Okay, the human language is the highest language, while the computer language or the machine language is the lowest language. The machine language again, or the binary language, which is the native language or the dialect of the machine, we consider that as the lowest language. So somewhere here, up above, near the human language, are those high-level programming languages, okay? Because they resemble a human language. Like C programming, for example, okay? Recall the program we have. Take note that there are English words, right? Like include, main, void, int for integer, and then print, f, print to print on the monitor, to scan the keyboard. And this notation is a mathematical notation that is very common to human language. So notice that the C programming language contains English words, and that means it is easily understood by humans. So again, high-level programming languages are those that resembles human language, while the low-level are those languages that's not necessarily the same as the machine language, but closer to the machine language. And one of that is assembly programming language. So when we write the algorithm, it is somewhere here because algorithms are written in human language. And then once we have the algorithm, we rewrite that into a program using a programming language. Say for example, we use C programming language, then the algorithm will now become a C program. Now, notice that the C program contains English words. It's not binary language yet. And so, the computer, which is a machine, cannot actually execute this one yet. So, what happens is that we have a compiler. A compiler is, look at the definition, a compiler is a program that translates high-level language program or code to machine language. So compiler is a translator. It translates one language to another language, where that one language, the source code is high-level language and the output is low-level language. So the C program is called the source code. The source code or the source program. So this is source code or source program. This is an input program to the compiler. So the compiler is a program that translates the source code C program into what is the output of the compiler. We call it the object code or the object program. So this is the output of the compiler. So we have an output object code or object program. So this one is a C compiler. That is why what we did earlier is that when you run it, you first need to compile it. This shortcut button will allow us to compile this C program. To compile means to translate this high-level language program into low level so that the computer can understand it. So the C program we have in here, say for example, sum.c. So that is compiled, and then what we have generated is an object code. So this is the source code. When we compile it, this is generated, the sum.exe. So that is now the true executable code. Notice that when we double click it, it runs or it performs the instruction. Okay, take note that the type of that file is application, meaning executable. That's why the extension is .exe, .exe. So the machine language is the native language of the computer. Programs that are written in this language consist of zeros and ones. So in this hierarchy of languages, when you go up, the language becomes understandable to humans. When you are going down, the language gets closer to the machine language. It is not easier to understand by humans, but machines can easily understand it. Going up, it's more easy to understand by humans, while it's not easy for computers to understand. That's why you need to compile it or translate it. Going down, humans will have a hard time of understanding it, but the computer will have an easy way of understanding it. Another term we have here is operating system. Okay, operating system examples are Windows 95, 98. These are old versions of Windows. We have now Windows 10. We have Windows NT. We also have Unix. Linux is also an operating system. What is operating system? It is simply the main systems program on a computer which controls and manages all other programs. So this is like a platform on which all other software applications run. Now remember, when you buy a computer or a laptop, when there is no operating system like Windows, you cannot install any software application. So you need to install the operating system like Windows, and after which you could then install any other software application. So it is the manager and the controller of applications. So it's like this is the operating system, and these are the applications, like you have here dev C++, you have here notepad, you have here Microsoft Word, Excel, PowerPoint, and maybe your games. This part here is your computer's resources, like the hard disk drive, the printer, the keyboard, the monitor, etc. So say these are the computer resources. What the operating system will do, being the manager and the controller of the computer's resources and the software application, is it is the one that will manage how these applications will use the computer's resources. Say for example, Microsoft Word would send a printing job to the printer. The OS will say, okay, go print that data. While the printer is printing, say another application like Notepad is sending another printing job to the printer. Then the OS will say, wait in the queue because the printer is still busy. So that's the job of the operating system. It is the manager of the software applications installed in the computer, and also the one that manage the computer's resources, making these resources available to the applications.